Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is aldol condensation, one of the most important carbon-carbon bond forming reactions in the entire aldehydes and ketones chapter. Let's begin. Aldol condensation genuinely requires the carbonyl compound to have at least one alpha hydrogen, a hydrogen atom on the carbon directly next to the carbonyl group, since this specific hydrogen is what actually gets removed in the very first step. In the presence of a dilute base like sodium hydroxide, the base removes an alpha hydrogen, generating a resonance stabilized carbanion called an enolate ion. This enolate then acts as a nucleophile, attacking the electrophilic carbonyl carbon or second molecule of the exact same aldehyde or ketone. This addition step produces a beta-hydroxyaldehyde, called an aldol when starting from acetaldehyde specifically, or a beta-hydroxyketone, called a ketol, when starting from a ketone. And this product genuinely contains both a hydroxyl group and a carbonyl group. The aldol product itself is genuinely just an intermediate. Under the specific reaction conditions, mild heating, in particular this beta-hydroxycarbonyl compound readily loses a molecule of water in a dehydration step. This elimination is favored because it produces a new, genuinely conjugated SEM, an alpha, beta-unsaturated carbonyl compound where the newly formed carbon-carbon double bond sits directly next to the existing carbonyl group. This full two-step sequence, addition followed by dehydration, is exactly why the overall reaction is called aldol condensation rather than simply aldol addition. Condensation specifically refers to a reaction where two molecules combine with the loss of a small molecule, here water. The final alpha-beta unsaturated product is genuinely more thermodynamically stable than the aldol intermediate, precisely because of this extended conjugation between the double bond and the carbonyl group. The single most critical, most frequently tested prerequisite check for any JEE aldol condensation problem is genuinely confirming the carbonyl compound actually has at least one alpha hydrogen available. Compounds entirely lacking alpha hydrogens, like benzaldehyde or formaldehyde, simply cannot undergo self-aldol condensation at all, and instead they undergo an entirely different reaction, the Cannizzaro reaction, under similar basic conditions. A frequently tested trap involves genuinely distinguishing between the aldol product, the beta-hydroxycarbonyl compound, which forms under cold, mild base conditions, versus the fully condensed, dehydrated, alpha beta-unsaturated product which forms specifically once heat is actually applied. JEE questions often ask specifically which product forms under a given, particular set of conditions. Also remember that closed aldol condensation between two genuinely different carbonyl compounds each possessing alpha hydrogens produces a genuine mixture of up to 4 distinct different products, since either compound can act as either the nucleophile or the electrophile. Let's recap. Aldol condensation needs a carbonyl compound with an alpha hydrogen. The dilute base removes that hydrogen to form an enolate, which attacks a second carbonyl molecule to give a beta-hydroxyaldehyde or ketone, the aldol. On mild heating, this aldol loses water to form a more stable, conjugated alpha, beta-unsaturated carbonyl compound. Remember, no alpha hydrogen means no aldol condensation. Those compounds undergo the Cannizzaro reaction instead. That's aldol condensation. Keep the alpha hydrogen prerequisite and the addition then dehydration sequence sharp. They're the foundation for this entire reaction family. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.